discussed, right, we've seen a bunch of things, right? So we saw that things like PageRank, they used popularity as a measure of relevance, and the design of the algorithm itself leads to this rich get richer kind of a phenomenon, right? And then we saw further things of how the rankings, they can amplify biases, right? Self-selection, and these end up creating feedback loops, right? So again, the point was that algorithms have a role to play in terms of how these feedback loops emerge, and they can amplify inequalities that might exist, right? We also saw that they do have an impact, right? This study talked about that. Similarly, we saw in news feeds that the absence of any correcting that there is an app, right? You can validate, right? That is there any correcting mechanism, and there wasn't any, right? So there were all these things, and then we got into machine learning, and we saw that many other issues can also arise, which can cause discrimination, right? So in terms of the sampling which has been considered, in terms of the target variable, is it the right variable being measured? Is it a proxy variable? Are there biases on the proxy variable which can then get amplified, right? Then if you do want to restore some sense of non-discrimination or fairness, then over there also there are many definitions, right? So it's not that there is one clear definition. Different stakeholders may have different definitions of what is fairness, right, or what is unbiased. We briefly saw that these can be mathematically represented. You can actually solve for these things in using classifiers. Right, similar things apply when it comes to ranking. Right, so just like with machine learning classifiers and different mathematical notions through which you can specify fairness. Similarly, you can specify it in ranking as well, right? And these are some mechanisms that can help counter whatever feedback effects might be introduced because of a proxy variable which is serving as a target variable and which has problems in it, or similar feedback effects that are caused, right? Right. So there are some exceptions that we saw, and then these problems may happen not just at the classification or ranking stage, but it may also happen at more upstream stages, right? So word embeddings, for example, is one innovation that has become very popular, and it's used as an input for many classification and ranking kind of tasks, right? So here, if there is a discrimination, and here the discrimination is really reflected in the language itself through which these embeddings are learned, so that can amplify further when it comes to the classification, right? So there are ways to detect discrimination, ways to improve, right? So this sort of gives you a big picture of how these feedback effects can operate due to many issues, right, at different stages. When you, let's say, deploy an algorithm or you have a machine learning model at some point in your pipeline. Yeah. We saw that, right? So this particular reading is quite interesting because it says that, well, on the one hand, there is of course politics, right, in terms of figuring out what's the right fairness definition to use and so on. So how you decide that becomes important, but not just that. What Iris Marion Young reminded us that trying to restore some kind of fairness in the resource allocation, which is what Rawls did, right? So now you can remember what Rawls, right, the difference principle. So the first principle was about everybody having equal access to opportunities. And then the second principle was that any inequalities that still do emerge, they should be in the service of those who are least well off. And they should not have arisen for any reasons related to those liberties, right? So what Iris Marion Young's criticism about this whole framing was that it is centric on resource allocation. So it's essentially looking at equality in resource allocation, but that alone is not sufficient because these inequalities were actually produced by underlying social processes. So those social processes have to be fixed. Now, how to then fix those social processes itself, right? So that means that the algorithms, right, just by ensuring fairness or discrimination in allocation decisions, that's alone not going to be sufficient. But a longer term view has to be taken that maybe you need affirmative action, maybe you need positive discrimination, so that generation by generation, right, these problems can be, the social processes themselves can be fixed and neutralized, right? So this is sort of the, in some sense, you can say a more formal argument, right? That where we have reservations for lower caste groups or for races, like in the US, where there's affirmative action and so on, or in Africa, for example. Right, so this is more of a formal argument around that, that just by countering discrimination in like recruitment is not sufficient. It will not solve the problems, but rather giving, right, this affirmative action, right, giving, guaranteeing certain positions, and right, so these are processes that can gradually over the generations that can restore more equality. Yeah. Right, so that's basically the idea, and there are various, right? Then we saw that, okay, all that is fine. How do we even check whether there is discrimination happening or not, right? Because as we know, there are, all the principles have been crafted and certain regulations may have been made, but they may not always be followed, right? So we looked at this area of black box algorithmic testing, right? And here we saw things like the Simpsons paradox, that there can be, that once you model more and more variables, it will reveal relationships, right? So there can be confounding relationships that can influence the result that you're, or the inferences that you're trying to make, and there can also be unknown variables. So while testing for discrimination is very important and it will lead to important questions, but drawing conclusions from it can, may not be very straightforward, right? So the main use of discrimination is probably not so much to point out that there is discrimination or not, but to actually raise questions, right? That these numbers or these metrics seem to be off, right? We should investigate them more deeply, right? So that's one of the points to keep in mind, right? Especially those of you who want to do projects on some of this, right? You should definitely keep this point in mind, that don't think of your project as, right, I want to detect that is there discrimination or not, right? That will be very hard, because you may not have taken all variables into account, or right, or confounding relationships and so on, right? But what's important is that to raise questions that, okay, we've measured these kinds of metrics. There could be discrimination, but now it needs deeper investigation. So these deeper investigations can come through a lot of qualitative studies as well, right? So it's not just that we want to measure and quantify everything, but qualitative studies are also quite relevant. Yeah. And then we saw that this is now true not just in classification or ranking, but many other domains, right? You come up with similar kinds of issues of discrimination or related, right, injustices that you can say, right? Like ad targeting, where categories are defined. Right now, you know that human behavior is self-selective. So if some of these self-selective categories are normatively not ideal, right? Like a self-selective category that, okay, we know that there are Jew haters in the world, right? But should we allow targeting of ads to that category? Right? Should we allow some, let's say, politician who wants to run an ad on Facebook, that I want this ad to specifically go to Jew haters because I want to appeal to that community, right? So that should be disallowed, right? Similarly, there are other systems, right? In recommendation, in online marketplaces where there are two-sided markets, right? Similar kinds of notions of unfairness, discrimination come in over there also, right? So we'll get to system design today, and right, these two questions, right? That, okay, given all this, right, what all problems should we try to solve in the algorithms itself, and what all problems require wider laws or other kinds of design practices to follow, right? So that's something we'll see as we go along. Yeah. Okay. Yeah, this part we skip. Right. Now the point is that given all this, right, how should we go about thinking about where to deploy algorithms, how to improve them, right? So here we saw that now critically there are many different perspectives with which people have been talking about. So we see papers. Now this is where you need to critically examine these kinds of studies, right? So there are papers which say that, well, how can we improve the acceptability of artificial intelligence technologies? And they look at, well, if we make them more humane, more human-like, then that's what we should do, right? Right. But the point is that why are they even taking this kind of a lens, right? Because they're moving from the assumption that these technologies are useful, right? So once you make that assumption that a particular technology is useful, then you ask a question that, okay, how can I make it more acceptable? Very similar to nudging, right? That once you decide that there is a nudge, right, like a positive or a good nudge which will be useful for social welfare, yeah, then you think about, okay, how do I implement this nudge, right? But the fundamental question is that, is it suitable or not, right? So that's something that many of these papers don't ask, right? And this is something that we see. In fact, if you go to different conferences, you'll see different views, right? In the sense that certain conferences are more, right? There's a community where certain papers are more common in some conferences than others. So that's something, right? Even in science, right? Now, as you can see, just like there is division in terms of what technologies are useful, which one should be done, how should they be done. Even in scientific research, the same thing is mirrored, right? Science research also, for example, draws its funding from corporate or from government, right? So the kind of research that we do, how we motivate our problems, that is influenced definitely by also who's funding us, for example, right? And wider motivation. So this, of course, we'll see in more detail once we start understanding the political economy, right? But broad point is that many of these views are reflected in also the venues, the conference venues, the publication venues that we see, right? Some of them are not so mindful of asking, right, what is it actually meant for, right? Rather than going to the second level question that, okay, assume that it's good, it's useful, right? How can we make it more acceptable in this case by increasing the humaneness? Then similarly, there are other ways which talk about efficiency, right? That, okay, these technologies are useful because they enhance efficiency. So now what should we do, right? What practices should we follow so that technologies improve efficiency even more? Yeah. But again, the point is that, is efficiency the most important value that you should be taking into account, right? What about fairness? What about justice, right? So which of these values is actually driving your principles? Yeah. Similarly, explanations, right, is also very useful. Explanations, as we saw, can also help improve the models. It can improve the accuracy of the models also. It can give more power to the people because they can now understand why a particular decision was made. They can appeal against the decision. So once they know the background, it can become easier for them to appeal against decisions as well. So explanations can be good. But on the other hand, also, explanations can also be used as a tool for increasing acceptability. Yeah, right. Same thing, right? Like in advertisements, that this particular paper, for example, talks about, and it raises many questions, right? That there are many ways to show advertisement, many ways to show explanations of advertisements. Some of them increase, right? Some of them might alienate users because it appears very creepy, but some of them might be useful, right? So, right, some of them might convince people that, okay, algorithms are fallible, but on the other hand, some of them might convey to people that algorithms are authoritative, right? So again, there are many ways in which these can have implications on how users perceive algorithms, right? So just like humaneness or efficiency, right, this also becomes a tool, in fact, right? So explanations can be used as a tool for both good as well as for bad, right? Right. So that's some of the important points also, that don't just take anything on face value, right, on whatever claims are being made, but there might be deeper implications, deeper incentives behind some of these things. Yeah. Right now, so we looked at explanations also briefly, right? So you can generate so things there are linear models and linear regression, logistic regression, which help you understand the effect of particular values, right? So it's useful to understand. Then you have decision trees, which basically show you the entire logic of how a decision was made. So that's also easy to understand, right? But with more complicated random forests or deep learning and all the other classifiers, right, it becomes harder. So there can be things like partial dependency plots that you can see, which can give users a sense, right, that had some particular variable been different, maybe a different decision could have been made, right? So there are these kinds of things. There are many other models which have come up, like having surrogate models where you have linear models that try to replicate non-linear models. So, and then the explanations are derived from the linear models. Linear models won't be able to replicate non-linear in all the cases, and therefore you also have local surrogate models that have been proposed, right? So lots of interesting things, different right methods in deep learning where you try to find out, right, what are the features which are causing the particular output, right? So that can also tell you quite a bit about, right, which factors are important. So something like partial dependency plots. And then these can also be useful, right? So like we said, it can be useful to improve the robustness of the algorithms by many of these methods, right? So in general, it can be explainable AI is another very active research area. So it can have many advantages, but of course, in terms of the application, right, it makes sense, right, if it's used for good things. Yeah. So after explanations, then we saw that okay, now given all these complexities with deployment of algorithms, right, we need some other checks and balances as well, right? Now, this is where we saw that where one part is algorithmic appeals. That wherever some of these algorithms have been deployed, it should be possible to also appeal the decision. Right? This is especially true when it comes to recruitment, where algorithms might be sifting through CVs of people and trying to recommend some of them, or like in criminal recidivism studies, right? So these algorithmic appeals are therefore, right, this can be one way to do that. Then we briefly discussed that some other ways can also be that the algorithm design itself has been very mindful of wider implications. And here we saw the case of a unclaimed baggage identification system in airports. Right. So an ethicist stayed with the team through the entire technology development process. Right. But this we also found was the author reports that it was very difficult. Right. It was very difficult because the requirements kept changing, the choice of technologies kept changing. So it was very difficult. Right. So the actual software engineering environment in a company is very dynamic, and it may not be straightforward to say that well some particular ethical practices should always be followed, right? So it's not that straightforward. We saw something similar when we were discussing privacy, right, where even though now privacy regulations are coming in and they have many companies have positions for a chief privacy officer, but in day-to-day practice it's difficult, right? Because right, how much power does this privacy team have to influence decisions, at what point are they brought in, right? All of that makes a big difference, and largely it ends up being more as a compliance measure, right? Just to sign off that okay, we've maintained this documentation or we did these kinds of checks, but it may not be very useful. Yeah, right. So this basically led to one of the main questions that, okay, this is great. Now, where all should we really be deploying algorithms then, right? Right, because we know that there are all these issues that do arise. So many of these issues we've been talking about, right? Allocative, representational, then whether explanations can be useful or not, right? Are you building the right safeguards through algorithmic appeals, right? So what are some environments where it is more straightforward to deploy algorithms versus not so straightforward to deploy algorithms? And in these scenarios, you'll need a lot of other checks and balances, right? So this paper took the example of basically what they call street level bureaucrats, right? So these could be people like police officers or field officers on the ground who are making day-to-day decisions, right? Who to enroll, who to give help to enroll for a government scheme, for example, what to do about it, who to give some entitlement to. So there are all these decisions being made, and on the one hand, you say that algorithms will be objective, and if individual people are deciding, then all their biases and everything come into the picture. But algorithms can be more objective, right? But then we know that there are all these other problems with algorithms as well, right? So what this paper basically suggests ultimately is that you contrast the work of a police officer with an accounting office, right? That should you deploy algorithms in a straightforward manner for police work, or should you deploy algorithms in a straightforward manner for accounting work? Yeah. So this is where, right, they say that, well, there are certain tasks which can be broken down into small steps. They are less complex, and there is a high repeatability of the same operations. Okay? Those are tasks which are more amenable to automation versus other tasks where there is no template as such. There are often a lot of deviations that happen from the template. Those are probably not things that should be in a straightforward manner deployed for where algorithms should be deployed, right? So it's in fact something to think about, right? Something we can also think about, and I've not had a chance, but I think this is an important area, right? That is it even formally possible to define, right? So just like P and NP problems and so on, right? Is it possible to formally define, right? And what is that class of algorithms where values beyond just accuracy and efficiency are important, right? Because if you're looking at systems which are where there's high repeatability, less deviation from normal course of the problem statement, then right, maybe just accuracy and efficiency is all that you need. And that's typically what we study, right, in algorithms courses everywhere, right? Mostly in all of computer science, right? That's what we largely study. We're largely just looking at accuracy and efficiency, right? How to do things faster, how to do things with less resources, memory, right? Computation, right? So, but where is it that it's not the case, right? So, what
So
are these classes of algorithms? Maybe where the social outcomes are necessary, or so that we are talking of social processes, right? So, how do we define that formally? Yeah.
so
So,
one example could be delay tolerant networks or Gramwani, where efficiency or the fastness is not important, but the content is important, or the network is important. So DTN is a good example for that, right?
mhm. I didn't completely get the point, Amit. So, okay, I see what you're saying. So things like delay tolerant networks,
Right.
where
Con-
you might, yeah, so your goal might not just be accuracy and efficiency, but your goal might be to eventually get data even across disconnected environments.
right, right.
Right, exactly.
Ev-
Yeah.
Even like Gramwani, which you have access to. So uh, it's not about the connectivity. It could be they can make use of the bus or whatever, like cycles, and still
Correct.
the people can get the videos and they can get their desired content. So there, I
Correct.
don't think like efficiency is important, but at least access to a service is important, and which
Huh.
they can get eventually later or sooner, whatever.
Correct, correct. Yeah, I think that's a good point. So I think that's one part of what we're saying, right? So essentially here we're saying that certain things might not be economically right justified. So for example, companies don't want to set up networks in villages. Telecom companies don't want to set up networks in villages. And why is that? Well, it's just simple economics. Because the population densities are low, people in paying capacity is low, so they will not be able to recover their costs, right? But still, it is important, right? Why is it important? It's right. It's not an economic argument. It's a more social justice argument that you do need to provide connectivity in remote areas as well, right? So that's one example where we are going beyond just looking at values of right economic values, for example. Right. So you can say that accuracy and efficiency are like economic values. So just a minor point, right? That this is also where regulations come in, right? So for example, now how do you then incentivize companies to also open networks in rural areas, right? So the government typically, most governments have a fund which they call the USO fund, Universal Service Obligation Fund. So what this does is that for every cell phone tower that a company puts up in an urban area, they also have to pay a certain amount of fees into a kitty. And this kitty builds up, which is the USO fund, and then the government can deploy it. So governments have typically used this USO fund to set up cell phone towers in remote areas and which are then shared. So then they give this tower on a shared basis to multiple companies. Yeah. So that's one example. And same with Gramvani, right? So our reason for working in environments is precisely this, that we're not really making money. We're not really making a profit, but it's actually bringing greater inclusion, right? So inclusion becomes one factor. Yeah. So same with algorithms as well, right? Same with algorithms that you may not just need to look at the economic efficiency kind of metrics, but many other factors are also important, like a discrimination or perpetuation of structural injustices, and then that can actually tell you that maybe you need you need to make a distinction, just like the rural urban distinction in cell phone towers. You need some kind of a distinction even for places where algorithms are deployed. That in certain environments, there need to be more regulations. There need to be humans in the loop, right, who are checking these decisions, or there need to be appeal procedures and so on, right? In certain categories where algorithms are deployed, and in certain other categories, it's easier. So it's easier to deploy an algorithm. Yeah, where you're just looking at regular metrics of accuracy and efficiency. Yeah. Yeah, so I hope the broad narrative around this is clear, right? That we need to think deeper, right? We can't just be putting up algorithms wherever we want, but we need to think deeper, that there are certain spaces where it can be risky, and especially these are places where we're trying to model social processes, like right, where you might involve variables like some protected variables like race and so on. Decisions are contingent on that, right? So there are certain categories where you need more safeguards, right? So what this paper, for example, essentially says is that one way to think about it is to see the environment, where what are the activities happening in this environment, right? Are they very templatized, very predictable kind of activities, in which case automation is useful. Automation through algorithms can be straightforward, but in many others, it may not be. Yeah. So that's the point. Great. So we'll go further, right? Now, right, a lot of these broad category of systems are called human in the loop systems. That you can't make decisions without having a human in the loop, who verifies or who does a check on these algorithmic decisions. Yeah. Sometimes, however, also it's a question that sometimes the humans might just be playing a rubber stamping mechanism. Right? The algorithm is still making all the decisions and is explaining his decisions and so on, but regulations say that there should be a human in the loop. So the human in the loop is basically just rubber stamping that, yeah, okay, this is fine. The algorithmic decision is correct, right? So this particular paper is also very, very interesting, and it's actually a very good paper. So it talks about how it actually tries to compare that, right, same in the recidivism kind of study. Here it basically tries to compare that the algorithm produces some risk assessments. Yeah. And it tries to see what is the effect of this risk assessment on the humans who might examine them, right? So it makes one group of people who just look at the case history, like something like this, and then they give their decision. How likely is this defendant to be arrested before trial or fail to appear in court for trial, right? And the other group, they give them the risk score, which is given by the algorithm. So the idea is that once the judges have access to the risk score, it will affect their judgment. And then they see the result, right? And so they're essentially trying to examine what is the effect of showing the risk score to the people, to the judges. Is it actually helping make better decisions or not? Yeah. right? So now, so this is very interesting. So the control group is where they were not given a risk assessment, and this control group made quite a lot of mistakes. Then there is a group which is given algorithmic assessments and they actually do better. And then they also saw that what if you just take the algorithmic decision itself, and that did even better, right? So this is interesting that all said and done, the algorithms are making a much better decision, right? But also the point that they are also influencing people, right? Right. So there's a difference from 17.7 to 14.8. So they're actually causing this influence is moving in the right direction. And this further, the algorithms, however, are actually able to do much better, right? If you just had the algorithm just doing everything for you. Yeah. There is, however, right? So the difference between blacks and whites that still persists, though, right? So here in the classifier, they did not do any fairness correction, it seems, right? So in general, you see that for the blacks, right, the green ones, the false positive rates are typically higher, right? Rewards are also typically smaller, whereas for the whites, the algorithms is able to do a better job. Right now, this might be the case for data, right? Availability of data or what, right? Similar proxy metrics, we know that the classifier learns. But the interesting bit is this particular difference, right? Then what they also did is that, well, okay, so one is that they interviewed all the participants, right? So 50% of the part, and here there is a variation, right? So it is important to note that this is basically a statistical result. Results that we are seeing are statistical, right? Averaged over many people, many judges. Individual judges are following different things, so you don't know, right? So if, for example, right, one mistaken way to interpret the study would be to say that, well, oh, it seems that algorithms are able to do better, so let's just use algorithms, right? But that is a statistical mistake, right? Because the fact is that these are averages. Actually, the judges are all over the place, right? So some judges, for example, use the risk assessment as a starting point. They said that, okay, right, so here they're using the algorithm authoritatively. They're saying that, okay, I'm assuming that the algorithm is right giving me some useful things. Now I see, do I need to change it or not? Right. So these participants are basically untrained, right? These are recruited from Amazon Mechanical Turk, right? Amazon Mechanical Turk is a platform of crowd workers, right? So, right, these are, for example, you can, right, people who sign up, they are allocated tasks, and these tasks could be some mundane things like transcription, right? If an audio is played and they have to write the transcript, which is used for machine learning. It might be used for, right, object detection. So, when images are showed, and then they have to write, right, is there a flower in the image, is there a cat in the image, and so on, right, and then they're of course paid based on these things, right? So the judges are recruited from Amazon Mechanical Turk, which means that they're also like unskilled, basically. They're not actually, they're not being trained as lawyers or judges, right? They're untrained people. But here there is a wide variation, right? Because 51% of the participants use the risk assessment as a starting point. 32% use their independent judgment and then incorporated the risk assessment. 6% follow the risk assessment completely, and 6% ignored the risk assessment completely. So they chose that, okay, I'm not going to look at it, right? So, right. So the right way to interpret the study is that that individual judge who's making a decision, that person is important ultimately, right? Because, right, that person could be in the 51% or in the 32% or in any of these, right? We don't know, right? So that's one important point to keep in mind, right? That in some cases they might be making better judgments than the algorithm. Okay. So then what they also did is that they divided the defendants between R less than C, for whom the risk assessment predicted by the algorithm was less than that assessed by the control group. Right. So the control group was also making their scores. So they saw that in which cases was the algorithm predicting less than what the control group was predicting, and in which cases was the algorithm predicting something more than what the control group was predicting, right? And then they saw what's the fraction of blacks versus whites, in these two cases, right? And here again there was a difference, right? So in the R less than C case, where the algorithm was predicting a risk score less than what the humans were making, there is not much difference between blacks and whites. But where the algorithm was making a higher risk score than the control group, over there the risk score influence for blacks was more than whites. So what this basically is saying is that there is a bias towards higher risk scores for black people, right? Because it is tending that in these cases where your algorithm gives a higher risk score, there is a tendency for people to take it into account more heavily for black people. Yeah. So there is a bias, therefore, also in terms of not just a bias in terms of how they interpret the risk score, but there is also a bias in terms of whether they consider the risk scores as more correct for black people than for white people, right? So right. So whenever the risk scores are higher, actually it has a higher influence on the judgments for blacks, right? So again, right, it's basically again saying that, right, not only do you need to look at the individual judge and where are they placed on all of this, but also statistically, actually, right, not just in individual cases, but also statistically they show that higher risk scores for blacks tend to lead to they have a higher influence on the judgments. Yeah. So again, right? So it's a very nice paper because it shows, right, a bunch of puts across a bunch of contradictions, right? That algorithms are doing better, right? So one way, for example, right? So just a thought, right? One way could be that, right, you instead of having one judge, you have many judges make similar decisions, right? And then average it out or something, right? So that can be one way, right? But yeah, the contradictions are, of course, that individual judges have different ways in which they interpret the risk scores, and then there is a bias, though, in how much importance are you attaching to a high risk scores for blacks, right? Right. So ultimately, the point is that humans are biased, and algorithms, right? It needs to be very carefully examined, right? How these algorithms are to be considered. Yeah. Now, sociologists have also examined this, right? So not just computer scientists, for example, that right. And here the point, therefore, right, something we've been asking, right, that what goal was chosen and why, what and how the problem has been modeled, right? This becomes important, right? What is the objective of the algorithm? Why was this objective chosen? Right? What's the target variable that's been identified? What are the independent variables that are being used for prediction? Right? So all that becomes, right. These are all choices that are being made, right? And as we saw, right, the space in which you're using these algorithms, variables you're using, all that impacts. And then what is the certification process for the data? Right? Because now we see that there can be biases in the data which can also amplify. Right? So this also becomes important to examine, right? And the fact that there are people at every point debating the models, cleaning the data, designing algorithms, tuning parameters, applying these algorithms. So these become important points to reflect on, and which basically goes completely against the common view in which we perceive algorithms, right? Because we perceive algorithms as very objective, but actually, right, there are so many underlying complications in how why we shouldn't look at it so objectively, right? Examine it critically. And this is in general a tendency because in general there is the scientific method, rationalist approaches are more popular. Now they also get their popularity largely because we've seen so much success in health, for example, in economic growth, in industrialization. Right? And none of these would have been possible if we had not followed some of these quantitative rationalist approaches of selecting what's the right scientific law that applies here, or what's the right engineering practice to use, right? So all that is very important, but the point is that we need to delineate, right, what are the limits also of these approaches, right? So in certain natural processes, that's the right approach to follow, but maybe in certain social processes, it's not the right approach to follow. So that becomes important. It's also exploited, right? So the objective view is also exploited because it also allows you to distance yourself from the algorithm, right? Because then now you're saying that, well, I didn't make any mistake, the algorithm made a mistake, and then it's up to the algorithm, right? So these are also certain points, right? So essentially the point of this paper is, right, basic questions, right? What really is an algorithm, and then how should we examine algorithms, right? Not just from an accuracy and efficiency standpoint, but we should look at it from, let's say, Taylorism, right? Taylorism, you will recall, we brought it up, right? So this is a Taylorist method of the assembly line, right? Industrial automation, right? Which was done primarily to put more control in the hands of the management, so that the management can control how the assembly line works, and it de-skills the labor, right? So now you need less skilled labor to do simple things on the assembly line. Labor is treated as a commodity. So this has, of course, very wide sociological implication, right? This is what Marx and everybody really talk about, right? So in the same way, we need to examine algorithms also from similar lenses, right? Or what things are being objectified, right? Value of life is being objectified. Similarly, right, for algorithms, you'll need more. Algorithms demand legibility, description of people in terms of vectors, right? So that also can take away, right, much of humanness from what we feel, right? Because it's a matter of which of our characteristics are actually datafied, right, and which ones are not. So these things are important, and then it's about, right, once you do put humans in the loop, right, who still has what discretion do they have? Has it completely removed the discretion from them and put it into the hands of the algorithms, or do they still have some power, right? So it needs to, right, so there are, right, very wide sociological literature which examines all of these things, right? So what the paper argues is that even algorithms you should examine from these much wider lenses of how they're deployed in society. Yeah. Right. Same. This paper. You should watch this video also. Quite. It's just a short 2-minute ad, basically, of right. So that in certain social processes, like in crime prediction, right, these are modeled as heat maps, right? That, okay, these are, and which you must have seen also, right? There's a lot of work, right, which tries to identify neighborhoods which are more prone to crime and so on. And then that is used as a predictive mechanism also. That, okay, then we should police these locations more than other locations because there tends to be more crime over here, right? But that's typically not how crime is operating, right? It's just a self-fulfilling kind of method that you police more, you'll find more crime over there, but crime might be happening in many other places, right? Right. So some of these things are subjective, right? And maybe it's not right to model policing as a disease, right? So disease would spread spatially, right? With disease spread, you can make these spatial models, but maybe with policing you should not, because it can cause problems, right? Similarly, marketing, where you're doing personalized advertising, right? These again can have different feedback effects, right? Right. So there's interesting, right, points to keep in mind, basically, to critically examine that where should we use algorithms, where should we use algorithms with safeguards, how should we build these algorithms, what factors are we modeling into these algorithms. All of that needs a critical reflection. Yeah. Cool. So I hope at least, right, the main takeaway from all of this, right, is that just like we saw with user interfaces, right, that any decision you're taking on how to make this user interface, right, it's not just a very functional way in which you should look at it, right? There are nudges, there are so many things that can happen. Whether you display a metric, right? How many people liked the story, how many people did not like the story, right? That has wider implications. So it becomes important to think about it, right? Same with algorithms, right? It's not just a very straightforward way to think about algorithms, right? As very objective, right? But how you're modeling, what objective are you putting on the algorithm? Especially data-driven algorithms can have other implications as well. And you need safeguards ultimately when you're talking about decision making algorithms. And same with data and privacy, that again, right, there are many ways to think about privacy solutions for some of these things, right? These become important points to keep in mind because they can all have very wide sociological, political impacts. Yeah, great. So another, right, this is an just as an FYI, right, that now we're talking about data and everything. So this is, people are also talking about. So this is in fact just a recent tutorial from KDD 21 and it's publicly accessible. So you can take a look. I mean, it's very economics oriented. So even I didn't understand much of it. But essentially they're talking about how to price data. And there are different ways in which, different points at which you can think about it, right? So one is the pricing of raw data sets. Then you have pricing of, because you would attach labels on these data sets. So raw data sets would be, let's say, images. Let's say Facebook or some company, right? Let's say Flickr, which has a very large database of images, or Instagram, they want to sell their images. So that's a raw data set. Then you have labeled data sets. Right? So labels meaning that now in these labels, somebody has identified that, okay, this is a cat, this is a dog, or some other, right? Whatever labels there might be. So there is a cost that goes into labeling, right? So that's right. Some people sell labeled data sets. Then you have models, right? So instead of selling data, you actually learn models on the data, and then you sell these models, right? So what's the pricing for these models? Then the other is that you don't even sell the models, but you deploy the models, and then you provide APIs. Right? So this is where, for example, you have Google APIs where you can query for transcription of audio. So you send an audio and you get a transcription of the audio. Right? So they've not made the models available or the raw data available, but just service of using these models. Right? So this, of course, is a complicated economic setup. It's still being worked out. There's no steady market as such. Right, some industries are more advanced, like in speech recognition. There are companies which specialize at different points in this. So some companies just collect raw data. Some basically put effort and draw label data. Right, some of them provide models, trained models. So here they've spent the computation overhead and the research in building models, and then they sell that. Right. So at each of these steps, there is value addition happening. Right. There is value addition happening, and ultimately there is a value that a user attaches to it. Right. So the point is how to distribute this value. So if a user is willing to pay, let's say whatever, right, just arbitrarily, right, 1 rupee for 5 seconds of audio transcription. I'm just making it up, right? So if that is the valuation that the user is attaching, and there are a million of such users who are willing to pay 1 rupee for every 5 seconds of audio transcription, then how should this value be distributed to the person that's deployed the model, or to the companies that have trained the models, or to the companies that provided the labeling on the data, or to companies that actually do the raw data, right? So these are economic questions which are also being examined, right? So these things will become more important as we go along, because data is being used more and more in everything, right? Not just in speech recognition, but in health, in urbanization, right? Where people are trying to study traffic patterns, people are trying to study movement patterns of people, right? So a lot of that is happening, and this pricing is an important research area also for doing this. Yeah. Right. So that's the point, right? So this completes this module on algorithms, right? So we've seen three so far, right? User interfaces, data and privacy, and algorithms, right? And right, the next one that we'll get into is now what I call system design, right? System design is that now we've seen that, okay, these are typically things we've done inside the technology. Yeah. That how can we make the technology better, right? Less discriminatory, think about nudges in the right way, make communication more private, and so on, right? So all of these are interventions that we can do from an ethical standpoint, ethical interventions that we can do in the technology itself. And maybe we can put up some processes around the technology as well, like human in the loop systems, and some of those can be very carefully crafted. System design goes to the next level that, okay, now once these systems are deployed, they actually have a wide influence on different users that are interacting with these systems, right? And this is also especially true in platforms. Platforms are like Uber, where you bring drivers and consumers together, right? Or Amazon, where you're bringing sellers and buyers together, and so on. Because the way in which you deploy the technology, right, that can change. Who are you favoring? Are you favoring consumers more than drivers? Are you favoring buyers more than sellers? And that is changing the dynamics, right? So again, the question of politics, that or let's say economics, right? That what's the more important entity for you to focus on, right? But that's what system design looks at. That you model all the stakeholders in the system, and then you see, right? That okay, when I introduce an intervention, what is going to change? So these sets of stakeholders have particular relationships with each other. When I bring the technology, what happens? What changes? Yeah.